In this video, we're going to look at some example problems from Chapter 19 dealing with interpreting confidence intervals for proportions. So the first question is, in January 2002, two students made worldwide headlines by spinning a Belgian euro 250 times and getting 150 heads. That would be 56%. That makes the 90% confidence interval 51% to 61%. We're going to look at several statements and try to determine whether they are correct or not. The first statement we want to look at is, between 51% and 61% of all euros are unfair. We are 90% sure that in this experiment, this euro landed on heads between 51 and 61% of the spins. We are 90% sure that spun euros will land on heads between 51 and 61% of the time. And if you spin a euro many times, you can be 90% sure of getting between 51 and 61% heads. And the last one, 90% of all spun euros will land heads between 51% and 61% of the time. So we're going to take each one of those statements one at a time. All right, the first one. Between 51% and 61% of all euros are unfair. So pause the video, put your answer down, and then we'll check it. $140 heads divided by 250 gives us 51%. So we are told in the original problem that our confidence interval of 90% is between 51 and 61. So the answer is this is not correct. Interval is about proportion of heads, not individual coins. All right, the second one, we are 90% sure that in this experiment, this euro landed on heads between 51 and 61% of the time. And again, on each one of these, I'm going to put that information from the original problem up. So try to answer it. And this is false. We know in this sample that 56% of the spins were heads. We are 90% sure that spun euros will land on heads between 51 and 61% of the time. Answer is true. If you spin a euro many times, you can be 90% sure of getting between 51 and 61% heads. This is false. Again, the interval is about proportion of heads and not individual spins. And the last one, 90% of all spun euros will land on heads between 51 and 61% of the time. False. The interval, again, is about proportion of, how do we go back? False. The interval is about proportion of heads, not the percentage of euros. Next question. Several factors are involved in the creation of a confidence interval. Among them is sample size, the level of confidence, and the margin of error. We're going to look at several statements and try to determine whether the statements are true. The first one. For a given sample size, higher confidence means a smaller margin. For a specific confidence level, larger samples provide smaller margins of error. For a fixed margin of error, larger samples provide greater confidence. For a given confidence level, having the margin of error requires a sample twice as large. So the first one. So you read the question, write your answer down, and then we'll talk about the answer. Okay, the answer is false. A higher confidence means a larger margin of error. This one is true. This one is also true. And that one is true. Okay, the next question is, what fraction of cars is made in Japan? The computer output below summarizes the results of a random sample of 50 autos. Explain what this means. So what we're given is that we have a random sample of 50 autos. z-interval for the proportion with a 90% confidence level is given. So write down what you think this is telling you and then check your answer. This says that we are 90% confident that the proportion of Japanese cars is between 29.9% and 47%. Next question. A study of 902 decisions to grant people or not made by the Nebraska Board of Parole produced the following computer output. Assuming these cases are representative of all cases that may come before the board, what can you conclude? So we're given 902 decisions, a z-interval for proportion with a 95% confidence level, and we know that the proportion is between 0.561 and 0.625. So write down what this tells you and then check your answer. This tells us that on the basis of this sample, 902 decisions, we are 95% confident that the proportion of paroles granted is between 56.1 and 62.5. All right, the next question reads, in December of 2011, Consumer Reports published a study indicating that 22% of 190 seafood packages were mislabeled. The first thing we want to do is construct a 95% confidence interval for the proportion of seafood that is mislabeled. So try this on your own and then check your answer. The things that we know in this problem are the sample size is 190, the percentage of mislabeled packages was 0.22, our z-star is 1.96, and then 1 minus p-hat is 0.78. When you put those into your confidence interval formula, you should have gotten 16.2% to 28%. Oops. All right. The B part, explain the confidence interval. We are 95% confident that the true proportion of mislabeled seafood is between 16.2 and 28%. And